Hello everyone, I'm back with another topic, motion under gravity. In this video we are going to solve some questions from the topic motion under gravity. So let us begin. The first question is two bodies of mass 1 kg. Two bodies of mass 1 kg and 3 kg are dropped from height of 16 meter and 25 meter respectively. The ratio of the time taken by them to reach the ground is. So the time taken do not depend the time taken for free fall does not depend on masses, so you can easily ignore this information. The second thing is from height of 16 and 25 meter respectively, so height is important. So if I draw the diagram, one is from 16 meter, one is from 25 meter, the second one is from 16 meter. Two balls are dropped, means initial velocity is 0. So in this case, you know the formula. If you will apply the equation of motion in the y direction, taking downward direction positive, the second equation of motion s is equal to ut plus half at square is the second equation of motion. You apply taking the downward direction positive, you will get s. What is s? S is the height. So height is initial velocity is 0, so h is equal to, here acceleration is g, so g by 2 t square. T is the time taken, so I can say that h is directly proportional to the square of time taken. So I can write this means what, that h by t square is going to be constant. H by t square is going to be constant. So I can write it as, if h by t square is equal to constant, then h1 by t1 whole square is equal to h2 by t2 whole square. So h1 is what? H1 is 16. H1 is 16 meter by t1 t1 whole square is equal to h2, that is 25 by t2 whole square. Now solving this you will get t1 square, t1 by t2, moving this t that side, you will get t1 by t2 whole square as 16 by 25. So from here easily you can say that t1 by t2 is going to be root of 16 by 25, that is going to be 4 by 5. So 4 by 5 is our answer. 4 by 5, A option is the answer. Moving to the second question. The second question says that the displacement of a body is given by half gt square. Sorry, the question has been hidden. The displacement of a body is given by half gt square. S is given as half gt square, where g is the acceleration due to gravity. The velocity of the body at any time t is. So in this question, the displacement is given, and velocity is what? Differentiation of displacement. So I can differentiate it. So what I will write, so ds by dt is going to be the velocity at any particular point of time. So d, instead of s, I'm going to write half gt square. So g, the value of g is constant for earth. For any planet, the value of g is constant. So I can write it as v is equal to, what is the differentiation? It will be half g is constant, so g by 2 will come out, and the differentiation of t square is g by 2, sorry, the differentiation of t square is what? 2t is 2t. So the velocity at any point of time is given by gt. So this is using calculus. Now what I am saying, this looks similar to the second equation of motion. So from here, s is equal to ut plus half at square. If you compare, you will get u is 0 in this case. So for velocity at any particular point of time, I can use v is equal to u plus at. A is what? A is g only, so v is equal to initial velocity is 0, so acceleration is g only, gt. So from both the things I am getting the same answer. So you can use calculus or the equations of motion, it's on you. So C is the correct answer. Moving to the next question, the ratio of distance traveled by a freely falling body in 1 second, 2 second, 3 second and 4 second. Using Galileo's law of odd number, you can solve this. What Galileo's law of odd number states: the distance covered by body, if a body is undergoing constant acceleration and the initial velocity is 0, so in that case the distance covered in first second, if the distance covered in first second is x and the distance covered in next 1 second, next interval of time would be 3x, and in the next interval of time, the next 1 second, in the next interval of time it would be 5x, and in the next 1 second, in the fourth 1 second, or in the fourth interval of time, it would be 7x. So the trend of odd number goes on. So 1 ratio, 3 ratio, 5 ratio, 7, and this so on, the odd number continues. So any question like this you can solve using the Galileo's law of odd number. So 1 ratio, 3 ratio, 5 ratio, 7, option D is the correct answer. Now a ball is thrown upward with an initial velocity of 10 meter per second. A ball is thrown upward. So a ball is thrown upward with an initial velocity u is equal to 100 meter per second. The time taken to reach the highest point, so this path it will follow. So what is the time taken to reach this point? So if you look carefully, the velocity at this particular point v would be 0. So considering this motion, initial velocity we have, final velocity we have, we know that the acceleration is equal to g, and we know that this g would be negative. This g we will take as minus 10, we will take g minus 10 because it is reducing the speed, it is decreasing the speed of the ball. So I will take minus 10. It is on you, what is your direction. So the height is not given, only the initial velocity is given. So using the first equation of motion, v is equal to u plus at, final velocity is 0, initial velocity is 100 plus acceleration is minus 10. What is time? Time we have to find. So 10t, coming this is equal to 100, so t is going to be 10 seconds. So B is the correct answer. There's a direct formula, if you can remember, that for this case, for vertical projection, the time of light, the time taken to reach the highest point, the time of light is 2u by g. What is the time taken to reach the highest point? So it will be half of it now. So t is t by 2, that would be equal to u by g. So using this formula also you can calculate t is equal to u by g. What is u? U is 100. What is g? G is 10. So you will get 10 second is the answer. From here both the cases 10 is the answer. Moving to the fifth question, it states that a ball is projected upward with an initial velocity 5 meter per second. So ball is projected upward with initial velocity 50 meter per second. So this is the diagram. Try to make diagrams, try to draw the visual picture of the scenario, then you will be able to solve the questions more efficiently. So the ball will be at a height of itna meter from the ground after. So what would be the time for which the distance covered would be 125 meter from the ground after with an initial velocity. So this is the question which we have. So we have so the ball will be at a height of itna from the ground after the time. So if you look carefully, if I draw the path, so let's suppose this is the height of 125 meter, 125 meters. So what is the time when it will reach this particular point of 125 meter from the ground? So at this point we do not know the final velocity. So we will use the second equation of motion, that s is equal to ut plus half at square, taking the upward direction as negative. No, we will take the downward direction negative and upward direction as positive. So the displacement covered is in the upward direction, so it will be positive. 125 is equal to initial velocity is 50, time we have to find, it is also in upward direction, initial velocity, plus acceleration is in negative direction, so minus g by 2, that is minus 5 I can take because g is 10, so g by 10 by 2 is 5 minus 5t. So solving this quadratic equation, 5t minus 50 5t square, so this is a square now, okay, so 5t square minus 50t, 5t square minus 50t is going to be 5t square minus 5t square minus 50t plus 125 is going to be 0. So we will solve this quadratic equation using the factorization method, middle term splitting. Before that I will take 5 common, so I am left with t square minus 10t plus 225 is equal to 0. So 5 cannot be 0, so this must be 0, so this must be 0. So solving further I will get my answer as t square minus 10t plus 25 is equal to 0. So think of two numbers whose product is going to be 25 and their sum is going to be 10. So that is what? 5 plus 5, 5 times 5. So t minus 5 whole square, I can write it as, okay, yeah, t minus 5 whole square is going to be 0, so t is going to be 5. T is going to be 5 second. So 5 second or 3 or 6 second is not the answer, 5 second is the correct answer, as I think so. Yeah, 5 second is the correct answer. Moving to the next question, the sixth question. A stone is thrown vertically upward with velocity 30 meter per second. What is the distance traveled by the stone during the first second of its motion? So a stone is thrown with initial velocity of 30 meter per second vertically upward. What is the distance traveled by the stone during first second of its motion? So let's suppose in 1 second it covers h distance. Final velocity we don't know in the first second. So using the second equation of motion, s is equal to ut plus half at square, ut plus half at square. S we have to find, that is h, initial velocity is 30, taking upward direction positive, time is 1 second, minus, because downward direction is negative, g by 2 is minus 5. Now t square is 1 square, that is 1, so 30 minus 5, h is going to be 25,